Let's jump right into this explainer. Today, we're taking on the absolute ultimate challenge in the Cambridge AS and A-level mathematics syllabus, specifically Code 9709. We are going to completely deconstruct your exam strategy by looking at two very common types of students I see all the time. First, we've got Alex. Now, Alex overloads on raw mathematical facts. Alex is like a walking textbook, memorizing absolutely every single formula, but completely misses the analytical depth that examiners are actually looking for. Then, on the other side, we have Sam. Sam genuinely understands the math, but Sam is a speed demon who rushes straight past the specific command word requirements. Sam misses those crucial foundational steps, and because of that bleeds crucial marks. Our goal today is to make sure you aren't an Alex, and you certainly aren't a Sam. We are going to turn you into a strategic master of this exam. To get you there, we're going to follow this 5-step playbook. We're hitting the 15% challenge, the core theoretical principles, the procedural framework, the top 3 examiner warnings, and finally, critical analysis and mastery. Section 1, the 15% challenge. Let's talk about the immense, high-stakes value hiding right there in paper 2. Look at that massive 15% right there. Now, that is not just a random statistic. Approximately 15% of your total marks in paper 2 are dedicated solely to logarithmic and exponential functions. Think about that for a second. That is a massive, massive chunk of your final grade wrapped up in just one single conceptual area. It's essentially the difference between 2 entire grade boundaries. If you can master this one specific area, you are automatically and significantly elevating your baseline score before you even look at the rest of the paper. And it absolutely all starts right here with the inverse relationship. This is the fundamental bedrock mathematical connection between the exponential function, that's e to the power of x, and the natural logarithmic function, ln x. You have to think of them as a mirror image. They are the mathematical equivalent of tying and untying a knot. One operation completely reverses the other. Now, this foundational concept is exactly where our friend Sam always crashes and burns. Students like Sam rush. They see a multi-stage equation and jump straight into trying to calculate a final number. But they completely miss the crucial first step of truly defining and leveraging this inverse relationship to simplify the problem before they ever start crunching numbers.
Moving on to Section 2, Core Theoretical Principles. Let's break down the actual conceptual framework you need to start unlocking those hidden method marks.
The contrast you're seeing here illustrates the exact mental shift you need to make right now. Over on the left, we've got generic, isolated knowledge. This is exactly where Alex lives, right? Just memorizing facts in a vacuum, completely disconnected from anything else. But over on the right, we have cross-topic mathematical connections. You see, the principal examiner reports explicitly tell us that the assessment framework prioritizes analytical depth way over superficial breadth. The examiners honestly do not just care if you know what a logarithm is. They want to see if you can integrate that logarithm with other areas of the syllabus. They're actively looking to reward logical structured reasoning and causal relationships, not just your ability to regurgitate an isolated equation. Before we get into the actual step-by-step framework, make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSC, to excel in your Cambridge examinations. Hitting that subscribe button and turning on the bell icon ensures you never miss these critical strategy updates. All right, Section 3, the procedural framework. This is where we turn theory into your method mark strategy. Okay, this is the secret sauce. The crucial point here is this standardized 5-step sequence. When you sit down and face a brutal question on exponential and logarithmic functions, you cannot just start writing numbers on the page. Step 1, deconstruct the question. You have to identify exactly what command words are being used. Step 2, extract the relevant data. Pull the actual numbers and variables out of the text or the tables. Step 3, apply your framework. And yes, even in math, we use a structure like PEL, point, evidence, explanation, link. Your point is the mathematical rule you're applying. Your evidence is the data you extracted. Your explanation is your algebraic working. And your link connects your final answer right back to the original command word. Step 4, execute systematically with incredibly clear notation. Show every bit of your working. And finally, Step 5, present your findings correctly. Use the proper headings, the correct terminology, and clear annotations. By strictly following these exact conventions, you are essentially forcing the examiner to give you those vital method marks because you're laying out your systematic processing step by step. Stop scrolling for a second. We've helped thousands of students improve by 2 to 3 entire grade boundaries just by taking these frameworks seriously. So join them right now, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations and turn on all notifications so you build these habits with us every single week. Let's dive into Section 4, the top 3 examiner warnings. It is time to uncover the trapdoors so you can step right over them. I want you to ask yourself this question right now. Why do so many capable students completely lose their method marks when conducting multi-stage analysis? Picture it. You are staring at a complex data table, the clock is ticking down, the pressure is on. You know the math, so what is actually going wrong? Well, the examiners have straight up told us what goes wrong, and it always boils down to these 3 specific warnings. Warning number 1, using the wrong approach for the specific context of the question. This is applying a formula blindly without checking if it fits the scenario. Warning number 2, poor format and presentation. This means skipping steps, having messy handwriting, or completely forgetting those strict notation conventions we just outlined. And warning number 3, providing generic answers that lack specificity. You literally cannot just write down a memorized definition of a natural logarithm and expect to get full marks. It just doesn't work that way. Let me read this examiner alert to you verbatim because it is that important. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. This quote is absolutely everything. An examiner isn't just looking for a correct final number, they are actively hunting for evidence-based reasoning anchored perfectly within the context of the specific mathematical problem you're trying to solve. If a question asks you to analyze a trend in exponential growth, you need to link your mathematical steps back to what is actually growing in the prompt. Generic math simply does not get grades. Finally, Section 5, Critical Analysis and Mastery. Let's synthesize all of this and put together the ultimate problem-solving system. I want you to take a mental screenshot of this cheat sheet right here. This represents the complete, foolproof mathematics answering matrix used by top-scoring candidates. It's split into 3 distinct phases: deconstruct, solve, and evaluate. In the deconstruct phase, your specific action is to identify the given information, with the ultimate goal of breaking this massive problem down into bite-sized logical steps. Then, in the solve phase, you execute systematically. Why? To secure every single one of those method marks we've been hunting for. But you absolutely cannot stop there. The final phase, evaluate, demands that you check the reasonableness of your final answer and justify your decisions with mathematical evidence. If your calculated exponential decay results in a negative population, your evaluation phase should catch that. This system forces you to question your assumptions and verify your results, rather than just rushing to a final number and crossing your fingers. Students who implement these strategies see massive improvements, but it only works if you practice it consistently. So drop a comment below right now with your target grade for mathematics and the biggest challenge you're facing. And of course, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCC to excel in your Cambridge examinations. So I'm going to leave you with this final pivotal question to chew on. How will you leverage the inverse relationship of e to the power of x and ln x to unlock cross-topic connections and secure that massive 15% of your exam? Don't just let this information fade away. Think deeply about how the procedural framework we covered today connects to the entire broader syllabus. Take this exact strategy, deconstruct the question, avoid the traps of Alex and Sam, and go master your very next past paper. Keep learning, keep practicing, and we'll see you in the next explainer.